Good morning, students. I am SK Salim, teacher in science. Today, I will teach you some of the formula related to refractive index for class 10 physics. Let's see. Before going to what is refractive index, we should learn about what is refraction. In brief, the refraction is the phenomenon due to which a ray of light deviates from its path while traveling from one medium to another optical medium. This is called refraction of light. For example, we can see, suppose this is the interface of a medium. Here medium 1 and this is medium 2. When light enters obliquely from one medium to another, obliquely means at the point of incidence, it is at an angle to the normal. If it comes from the rarer medium to denser medium, it bends towards the normal. This is called refraction. If the reverse happens, that is, it goes from a denser medium to rarer medium, then it will deviate away from the normal. This is the normal, and this is the refraction. The phenomenon of refraction is this, and we call this angle of incidence that is created between normal and the incident ray. This is incident ray, and the angle between the refracted ray and the normal is refracted ray, called refractive angle of refraction. So this is what refraction, and there are two laws that govern the refraction phenomenon. The first law is the incident ray. The refracted ray, the incident ray, the refracted ray, and the normal normal is this perpendicular to the interface. Normal lie in the same plane. Lie in the same plane. Where are the point of incidence? This point O, name it O, and they lie at the same point of the incidence. Lie on the same plane at the point of incidence and at the point of incidence. This is the first law for refraction. And the second law is the ratio of the sine of angle of incidence. The ratio of the sine of angle of incidence to the sine of angle of refraction is constant. This law is called Snell's law. It is named after the scientist Snell's law. The second law can be derived as a expression, that is sine I sine of angle of incidence divided by sine of angle of refraction is a constant, and this constant is nothing but the refractive index. This is the refractive index. This constant is the refractive index. This constant is a refractive index. It is important to remember that the sine of angle, the sine value of this angle to the sine value of this refractive angle is a constant that gives a constant value, that is refractive index, and refractive index are of two types. Refractive index are of two types. Refractive indices in plural. Refractive indices. It is two types. One is absolute refractive index. Absolute refractive index. Another is comparative, or it is called comparative refractive index or relative refractive index. Relative refractive index, absolute refractive index and relative refractive index. Absolute refractive index is when, if the medium 1, suppose this is the refraction what takes place, and if the medium 1 is normal incidence and refraction, if the medium 1 is air or vacuum, and it is any given medium. Is any given medium, then we can call it absolute refractive index of the given medium. So here we can define it as the refractive index of the given medium with respect to vacuum, the speed of light in a given medium with respect to the speed of light in the vacuum or air. This is called absolute refractive index. Then what is relative refractive index? Relative refractive index. Suppose we have this given medium is water or glass or turpentine, kerosene, etc., any transparent medium, and it is compared to vacuum or air, and the ratio we got is the refractive index. We have a refractive index or speed of light in certain mediums is, take it v1, when it is compared to the velocity of light in any given medium, another given medium, it is b2, then we call it relative refractive index. Relative refractive index. To understand the relative refractive index better, we should always keep in mind that it is the comparison of refractive index, not the velocity. It is the comparison of refractive indices of a given medium with another refractive index of another given medium. So that can be written as, suppose we are writing the refractive index, relative refractive index of medium 2 to medium 1. We can write the formula as n2 by n1. That is, the refractive index of medium 2 is compared to, with respect to the relative refractive index of medium 1. This is the formula. If we compare, suppose we are comparing the relative refractive index of n1 to 2, that we can write n1 2. That means relative refractive index of medium 1 with respect to medium 2. Here the formula will be the refractive index of n1, that is the relative refractive index of medium 1 is compared to with respect to the relative refractive index of medium 2. So this is how we can put the formula to get the numerical solutions. But whenever we use this word with respect to, with respect to when we use and we compare it in case of speed of light in given medium 1 by speed of light in given medium 2. Here with respect to word with respect to is used when we are using this. For this we use with respect to, that is the speed of light in medium 2 with respect to speed of light in given medium or medium 1. But in case of relative refractive index the reverse happens, that is relative refractive index of medium 1 with respect to medium 2. This is not to be confused while solving the numerical problems. So this is the formula you get for finding the relative refractive index, and for finding absolute refractive index or light speed of light in any given medium we use the formula, that is refractive index equals to, this is the absolute refractive index, this is speed of light in vacuum or air, and this is the speed of light in that given medium, and that gives the refractive index. These are two formulae to solve most of the numericals related to refractive indices. Now let's see some examples. Let's see what kind of questions you may be asked in your board exams. That is refractive index of diamond. Suppose diamond, the refractive index in diamond is given to you, so that is 2.42. 2.42 is the refractive index in diamond. Refractive index of diamond is 2.42. It is given, and what you have to find, you will be asked to find the speed of light in diamond. Speed of light in diamond, you have to find it. Now simply putting the formula, that is refractive index equals to speed of light in vacuum by speed of light in the given medium. Here we have the given medium, that is diamond. This given medium is diamond, and refractive index you have got here. So it is very easy to calculate the velocity. Now let's put the formula, that is C equals to, if n equals to c by v, then c, or speed of light in vacuum, will be equal to the refractive index multiplied the speed of light in that given medium, that is diamond, and this is what we have to find. Now we have the refractive index, this n, value of this n is in the given medium, that is diamond, is 2.42 V. So C equals to 2.42 V. Now V will be equal to speed of light in vacuum divided by the refractive index of diamond. This is actually where we got the answer by solving this. Now the value of speed of light in AR is found to be approximately 3 into 10 to the power 8. By putting this value 3 into 10 to the power 8 divided 2.42. What is this 2.42? It is the refractive index of diamond. So you keep in mind that to find the velocity in a given medium, that is diamond, will be equal to the speed of light in vacuum divided by the refractive index. This is the refractive index, and when we divide it, we got our answer. Okay students, now I think this video will be very helpful to you to find some of the problems, numericals in physics related to the refractive index. So thank you very much.